Today on Invertebrate Planet, first, marvels of nature's beauties. Next, invertebrates in the blackout. Only on Invertebrate Planet.
Hello, I'm Daniel Catenshmorough, and today on Marvels of Nature's Beauties, we're going to be looking at that most tentacled of animals, the cephalopod. I'm standing here at Pivot Island, the location of the Duke University Marine Laboratory, where unfortunately no cool cephalopods live. So in today's episode, we're going to be taking a journey around the world to observe these animals in their natural habitats. We're going to be paying close attention to the color-changing abilities of these animals and how different species use these abilities in different ways. Here we have a complex model of the average cephalopod. As you can see, the body is elongate and cephalized, with two large eyes that border a large brain. The mouth is surrounded by a ring of 8 arms and 2 long, sticky tentacles. But the transformative powers of the cephalopod lie in its skin. The cephalopod's skin is covered with tiny, pigment-filled cells known as chromatophores. These cells are surrounded by tiny muscles, which can dilate the pigment cup, making their color more vibrant. These chromatophores reflect yellows, oranges, and browns, but underneath them there are cells which do not change shape, but reflect color in blues and pinks and greens, and together they can create almost any color imaginable. They are shared by almost every cephalopod, except one. The nautilus. The nautilus is the most primitive living cephalopod, and, being a little bit old-fashioned, retained its ancestral shell, which is filled with gassy pockets that help it stay buoyant and make swimming very easy. They lack chromatophores, but have tiny sensors all over their tentacles which they use to detect prey within the sand. Their shell offers them grand protection, but their cousins have since lost it over evolutionary time, like this octopus, who is currently looking for a new home. The shell, at first glance, looks like a fine place to stay, but unfortunately, it is already inhabited. A sarcastic fringe head, a type of small but extremely territorial fish, has already made it its home. Using its chromatophores to mimic the color of the ground, the octopus attempts to sneak forward into the shell, but the sarcastic's keen eyesight alerts it to its presence, and it immediately begins to defend its home. Lacking a shell, the octopus is soft-bodied and very vulnerable, and it seeks to protect itself by throwing jabs at the fringe head. Sensing that its blows have done little good, the octopus retreats, and the fringe head is victorious. Having lost its first choice, the octopus has found a somewhat smaller shell that used to belong to a cockle clam. Holding onto it with its suckers and walking along the ground with its arms, it will use this shell for protection as it searches for food. But after all of the effort spent looking for the shell, perhaps hunting is best saved for later. Octopi that do not occupy small shells use their chromatophores to blend in with their surroundings. Here one has been blending in with kelp for God knows how long. Here another octopus is blending in with the coral around it. Using its highly sensitive tentacles and sense of smell, it detects prey somewhere nearby. This common octopus uses membranes between its tentacles to form an umbrella, trapping prey within a predetermined area. The umbrella is deployed. As it loosens the membranes between its tentacles and traps its prey, it turns them a shocking white color. This is used to startle the prey inside and scare it out, while the tentacle's tips will capture it and send it towards the octopus's beak-like mouth. In Australia's Great Barrier Reef, there's another cephalopod which uses its chromatophores for active hunting. The broad club cuttlefish. This particular broad club is on the hunt, and it has spotted a crab. First, disguising itself as coral, it attempts to sneak up on the crab, who senses its movement and immediately runs away. But cheap coral disguises are not the only trick that this cuttlefish possesses. It is also a hypnotist. The arrogant crab, thinking it has escaped the cuttlefish, runs away in the open. The cuttlefish begins its hypnotic strobe light display, and the crab is mesmerized. The broad club is able to swim right up to the mesmerized crab and pick it off. This broad club has found a crab of its own and is trying a slower pulse, but to no avail. The crab is unfazed. The cuttlefish sneaks around and, using its chromatophores, increases the frequency of the strobes. Double whammy. The broad club is not the only cephalopod which uses its chromatophores to dazzle its prey. In the mudflats of Indonesia, there is another. The mudflats are an interesting ecosystem. While they consist of only mud, the creatures that live here make up for it with incredibly interesting lifestyles, crazy shapes, and dazzling colors. But no inhabitant is more peculiar than this one. Walking around on stubby extensions of its mantle and its two front tentacles is the flamboyant cuttlefish. This cuttlefish too has found prey, and is strobing to mesmerize it. It has found a shrimp. Using its dazzling colors as a distraction, the flamboyant cuttlefish slowly walks towards the shrimp. When it is close enough, the cuttlefish reveals two long, sticky tentacles kept hidden within its mouth and captures its prey. But not all the shrimps here are so easily dealt with. A peacock mantis shrimp. This shrimp could deal a deadly blow with its two front raptorial appendages, and the cuttlefish uses an alarming display to scare it off. It is able to use its strobes for attack as well as defense. There are other, far larger cephalopods which use it for something else entirely. The Humboldt squid. This cephalopod is huge, reaching up to 7 feet in length and weighing over 100 pounds. Its tentacles are lined with hooks, and its beak is serrated and razor-sharp. It is traveling in a pack of hundreds, all here for the same reason. They're here to hunt these fish, who are themselves here to hunt a massive school of krill, several billion strong. The fish begin to sense what is happening and attempt to escape to the depths, but the squid chase them and herd them against the rocks. The squid begin to flash red and white, signaling their intents to their other schoolmates. Split down the middle means an intent to attack a fish, while more of a boiling, general pulsating color shows content and means that the squid has recently captured a fish and will likely not strike again anytime soon. By communicating so effectively, the squid, which are generally slower than the fish, are able to work as a team and pick off the school one by one. Each squid will eat several fish until they are all full, and then, quickly as they came, they disappear into the darkness. Today, we have seen that cephalopods can use their chromatophores for camouflage, for attack, for defense, and for coordination. The cephalopods are a truly spectacular group, full of some of the most vicious, the most colorful, the most intelligent, and the most delicious animals. They have colonized the globe much the same as we have, and their problem-solving skills rival that of even the most dexterous kindergartner. Without them, there would surely be no cephalopods. For Invertebrate Planet, I'm Daniel Catenshmorough. Be sure to join us next time on Marvels of Nature's Beauties.